Good morning, folks. Thanks for spending the next hour with us. There's a lot to share with you. I'm here to talk about the topmost layer of our ML services, which we call the AI services. And specifically, I'm going to focus on Amazon Rekognition, which is AWS's computer vision service for image and video analysis. So we launched Rekognition, Amazon Rekognition in 2016 with support for image. And in 2017, we added support for video. And we have added a bunch of features between 2016 and now. But at the base level, all Rekognition does is takes an input of an image or a video, does deep learning analysis of this content, and provides an output that then you could use for your application, business, or solution that you're working on. And specifically, what's interesting with Rekognition is that you don't have to have the deep learning expertise. You don't have to worry about gathering the large amount of data that you need to train these models. You don't have to worry about the quality evaluation, the training pipeline, the model deployment overheads, because we simplify all of it for you as a set of simple APIs that you pass an input of an image or a video, and you get the output as a set of labels with some confidence scores on it. So it really gets this high-tech, state-of-the-art solutions in your hand through easy, simple lines of code that all engineers can write. And that's really what we wanted to do in terms of getting these AI solutions in your hand. So the way you want to think of Rekognition is a set of features that supports images and video. And where it only does, some of these features only works for video, and I'll call them out so that you would know why. But you want to think of Rekognition as a set of features for images and video. And the first one that I want to talk to you about is face. And what we do with face is we can detect hundreds of faces from an image or a video with fairly high accuracy in all sort of different challenging, real world conditions that comes from different sensor location, lighting conditions, pose, and occlusion that normally are, occlusion is the common parlance of when your face is partially or fully hidden. And we are able to detect your face, and the detection is expressed as a bounding box around the face. We are able to then analyze the face to give you some very, very meaningful attributes that you could use to build applications and solutions for your customers. And these attributes are things like your gender, age range, emotion of the face, whether there's a facial hair, whether you're wearing eyeglasses, sunglasses, and many other such attributes. And then this face could also be used to search against compare against another face, which we call it face comparison, or search against a database of faces that you might have created. Now, all of this happens, again, through a set of simple APIs, works really fast, very easy to use, and scales well with your business and applications. A specific implementation of such face recognition that we have created for you guys is Celebrity. What we do with these features is that given an image or a video as an input, we are able to recognize hundreds of thousands of celebrities from globe across the world in near real time. A great example of this was our support of the coverage of royal wedding. And a couple of our customers created second screen experience for royal wedding. And this was against a live stream video that was coming from UK directly. And we were able to, in real time, recognize these celebrities that were attending the royal wedding, and the customer was able to create a much engaging second screen experience using this metadata that we extracted from them. The next set of features that I'll talk to you about is labels. And labels on the top and the scenes on the corner, they're kind of manifest of the same way. Idea here is, given an image, we are able to detect but a lot of the physical objects that you encounter in your workspace, in factories, in your home, in office, in your leisure, as well as some key concepts. And what is a concept? We know there's a chair because there is a physical object sitting there. There's a person, there's a physical object sitting there. But there are concepts like wedding. It's not about a cake or a gown or just a setup. It is a collection thereof that makes a wedding, and that's a concept in our world, right? Similarly, there's scenes like there's a sunset happening in this picture, that this is an indoor meeting room. right? There is no one particular signal that tells us, it's a scene that tells us there's an indoor meeting room. We are able to extract all this information from images and video and provide you with a fairly high accuracy confidence score when we find a match. A lot of our customers say, that's awesome, you're able to find faces and you're able to match them with other faces, you're able to recognize against large collection of faces, and you're also able to detect all these objects that are very useful for us. But there is a significant amount of text, words that are at times in images that be very, very important for us to find out what they are. So for instance, if I took an image of this room, on this chair in the front, there is this reserved for. So most object detection systems will not find that because they're not looking for characters and words. It's a very specific problem that typically you would associate with OCR. So we have text in image and video where we are able to extract fairly highly accurately text from images and video. So think of text as street signs, business names, ID, text in IDs and badges and so on and so forth. Next is a very important feature that we are providing for creating an experience where you can guarantee safety of content, safety of experiences with your customer, and we call it moderation. In moderation, we take image and video, and we are able to detect if there is inappropriate or unsafe content in it. Now, we go a step above and beyond saying whether it's safe and unsafe, and we'll get into a bit more detail in slides later. Now, the other feature I would like to talk to you about is activities. And activities, as I called out before, works only for video in this case. And the reason is, we are probably the only provider that uses the entirety of video to analyze it and give you metadata back. A lot of other providers typically take a video, creates keyframes, and does image analysis. Well, what you lose with that is a context of motion and a context of time that immediately impacts your accuracy, right? Me standing in one place, you get a frame of me here, I'm walking, and I come back here again, and if that's your next keyframe, you have completely missed out on my walking and motion, right? Now, how you normally trick that is that if I'm in an event like that and you have the context of the event, you could probably predict that I'm walking with a low confidence. But what better than actually tracking my motion and saying that he actually walked? So we are able to use every bit of information in the video to provide you very fine-grained activities with fairly high accuracy. Activities like somebody's walking, somebody's swimming, a baby's crawling, somebody's hugging somebody, somebody's getting into a car, somebody's getting out of a car, somebody's getting into the building, somebody's getting out of the building, somebody's playing soccer, somebody's running. These are possible because of this fine-grained activity detection that we have as part of our video analysis. The other aspect that we could do, because of the completeness of video analysis that we have in our solution, is pathing. In pathing, we are able to today identify a person, and when we say person, it's more than a face, it's of course your face and your body. Even when your face is not seen, we are able to detect a person and then path them through their motion in that video. Which means if a person walking on the back of this hall right now, we'll be able to path them with fairly high accuracy, even when they're partly or fully hidden behind another person or a physical object. It's kind of the same way human vision works, right? You know that there's a pillar, somebody walks behind the pillar and they emerge. You know that the person is still behind the pillar because you're using your a priori information and your post information that you know your experience suggests that they have to come out of that side, right? Unless it's a magician. So we are able to bring the same sort of information, same sort of technique to allow a very, very high accuracy pathing. And we'll tell you how that's useful for some of our customers. Finally, we also have, of course, a very high accuracy scene detection. So we could say this seems like a nightclub, this is an indoor conference room, there's a meeting environment, there's a sunset, there's sunrise, which could be fairly useful for customers depending on what you're trying to build. So in summary, the key benefits of these features and this API that we provide is that we are able to provide you a state-of-art computer vision capabilities as an easy-to-use, simple-to-call, easy-to-integrate API set. One of the advantages that we have is a large amount of customers have been using this product, and we'll hear a lot more about these customers later in this session. A lot of our customers are using this product, As with every AWS customers, we get a lot of feedback from them. That feedback is equal to iterations on the product, that's equal to improvement that you can benefit without changing a line of code. We are also low cost, and it's very, very fully self-managed and very easy to use set of APIs, as I said. So you can get started in a matter of days. Customers have been putting solutions in a matter of hours to days for some critical workload, which would have taken you months to build if you were to build this model yourself and train, even if you could get to the accuracy that we have gotten over a period of time. So we have been very fortunate with our customers. Pretty much from the day one, we have had many customers use us for production workload. As I said, a lot of feedback. The customers are ranging from media and entertainment, news, social media, public sector, banks, all sort of different vertical dating sites. They name them. We have customers from them using this product. And as you could see in the next slide, these are all customers that we can talk about that are using our product in production. I've been an active user of Rekognition and at least one feature of Rekognition today. And as you could see, the diversity of the vertical is so apparent here, right? On one hand, we have ad tech companies like Vidmov. You have News UK, a media company. We have dating sites. We have fintech. We have non-profit organizations like Thorn that are trying to solve human trafficking problem, complex problem like human trafficking. We are able to serve all these customers with this set of simple-to-use API that we have created. So now let's look into some of the use cases and zoom into some of the features that we talked about in the previous slides. As I said, we have a set of use cases around media discovery, customer engagement, safe content, and today I'm going to focus on these three. Of course, there are a few other areas that we are doing a lot of work on, and I'm sure there are other sessions we are doing today or later or in coming weeks that you'll be able to, if you want to dive deep, you can get more information on those. But today, particularly, I'm going to focus on media discovery. How do you use Rekognition to create better media experiences, both for your internal stakeholders as well as your external customers? How do you improve customer engagement using Rekognition? And how do you get a better customer engagement, better customer experience using Rekognition? And then finally, how do you create a safe content experience, both for your employees as well as for your customers using Amazon Rekognition? So let's start with media discovery. I needed an Alexa to tell it next slide. I'm not used to clicking. So media discovery, you have to solve a few problems if you're in the business of media. You can use Rekognition for live events. As I told you before, we had an amazing experience that a couple of our customers, Sky News and New York Times, created using Rekognition to create a second screen experience for the royal wedding coverage that essentially use celebrity recognition. You might have to create solutions for large media libraries and archives for your editorial content, for content discovery for your customer, as well as your other internal stakeholders. If you're in the business of dealing with user-generated content or social media, you can use Rekognition out of the box. And we'll talk to some really fun examples and use cases around those. And then finally, we're seeing a lot of use in kind of the ad tech, particularly in the domain of influencer marketing. And what influencer marketing tries to do, to just zoom into that a little bit, is that you have a lot of people that have a lot of followers in the social media. Their job is to target a product placement with these kind of ambassadors, as they're called, so that your product gets more eyeballs, right? And to do that, they need to understand if you want to put an ad on running, they want to find all these social media ambassadors who have images of running so that your product could be placed around them. Now, in the past, they were using human tagging. And if you look at some of the examples, and we have some examples that customers have shared with us, that when they were using human tagging, you could scroll through many, many pages and not a single image has anything to do with running. In fact, most of them had something to do with food for some reason. Whereas with recognition, once you pass these images through recognition and get the tags from recognition, now all of your images are related to running, so you could do a much better placement and much higher engagement and much better return of your investment for in these sort of kind of ad tech spaces. And that's what influencer marketing is trying to do. So the few tools the few needs and that you have in media discovery are who are in these images, what's in this image, and what's in the image, and we'll talk about what's in the image. There are various manifestations of that what and how you work with that, and then where. So for instance, this video frame from our Prime Video show now we can recognize in real time that these are the two actors that are present in this frame or this video or this image. And you could do this really effectively because we are taking the overhead of keeping this library updated. We add celebrities continuously. As we meet customers globally, they at times say, hey, I went to South Korea. There are a lot of customers in South Korea wanted us to cover South Korean celebrities. We came back, we had a set of South Korean celebrities that the system didn't recognize. And this iteration, this improvement happens continuously, which means you get to benefit from a much richer library with every call that you're making. Let's talk about the what's in an image. The what's in an image, from our perspective, manifests in a couple of ways. One is what we call the object and scene detection. Here, given an image or a video, we are able to find that there is a person in this image, there is a car or automobile in these images, there are skateboards, and there is road or asphalt in this image with fairly high accuracy. We are also able to find these concepts and scenes seem like there are a lot of architectural pattern in this image. Seems like there are some sporting sort of an activity happening here because this person is doing a skateboard. That there are parking in this scene somewhere. And then there is, because of the automotive, we also believe there's something related to transportation in this image. More scene, where, right, is, look, it's in the downtown. We believe this is a downtown, an urban center sort of a area, right? This is a city. Based on the buildings, we are predicating that this is a city scene, that there is a road here that this event is happening on. We launched object recognition in 2016 at reInvent 2016. We have been continuously improving the model by better accuracy, adding more labels. But I'm super excited about telling you that a couple of weeks ago, we actually announced our brand new object detection model that's available to you as part of the same API. We call it Detect Labels. And now we are able to, of course, create much higher accuracy label detection, along with provide you where exactly in the image the label is when the label is a physical object. So for instance, in this example, you could see that the picture is not very clear, but if you pay attention, there is a bounding box around the person. So in the previous cases, we were able to detect person. Now we are able to tell you exactly where the person is. So with this now, you could use solution like people counting, because we provide such high accuracy bounding box. Even when partial bodies available, you could count up all the bounding boxes for person and say there are 20 people in this room or 100 people in this room. We're able to detect all the cards, as you could see here, even when they're partially occluded. Some of the card that's at the end of the row, you only see some body of it. We are able to detect with fairly high accuracy. We are able to detect the skateboard with fairly high accuracy. We are able to detect wheels very high accuracy. Why is that important, by the way, beyond being cool? It's important because that helps you with a few things. Helps you with redaction. So for whatever reason, if you didn't want a person or the skateboard in this image, you could go redact that area because you know exactly which coordinates of the image this particular object is. Helps you with product placement, because typically what a lot of a customer tells us, I need to insert an ad, insert a text, insert something else on this image, and you don't want to overlay it on top of a person's face. So now you know where the person is. You could overlay the ad where there's a lot of empty spaces, right? So things like this could be done because now we are able to provide you localization of these objects in an image. Super excited about this. Also, what it allows you to do is get into a much more fine-grained analysis of image and video. Because of our bounding boxes, we are now able to find out where a person is, where the ball is. We already know that they are running or they're playing soccer. So you could now get into the wealth of world of sports activity, sports analysis with this tool fairly out of the box. The other what could be, what's in this image is a text. Text allows you to understand the street signs. Text allows you to understand, in this case, as you could see, this runner, if you pay attention, there are bounding box around the bibs. Now, we have a customer's photograph that have been using this to exactly, with high accuracy, know they support all these marathon events, where exactly the runners are. And with high accuracy, because all they need to know is where the bib numbers are. So even when they're running and their face cannot be seen, just a bib number tells them where the runners are, how they're doing, if they need help, if they need that, and provide better experience for the runner and their family, because if they're looking at a screen, they could say, hey, you can sign on for looking at this particular bib number and we can track them for you, right? So that's an awesome example of finding what's in an image that helps you create richer experiences. What's really interesting about our tech solution, and we'll hear a lot more about this in future slides, is that we built it to solve some very hard social media problem. And what we learned from that experience is that a lot of this text in the social media content are stylized, right? Where happy birthday is never written like normal English font. They're normally written in an arch form, happy anniversary written in a web form. How do you detect this text when they're stylized, when they're oriented well, so differently? And we spent a lot of time, our scientists spent a lot of time working with our customers to solve this problem. As a result, you could see that our text in image and text in video can solve these really difficult text extraction problem from image and video, even when they're oriented differently, when they're stylized font, in some cases even handwritten sort of script font, we are able to extract this text information from image and video. What's in an image? Well, this is the thing, this is the what in the image that you want to avoid, right? You don't want your customer, without at least you knowing, to be exposed to content that's inappropriate or unsafe. What makes the content inappropriate and unsafe in our domain is the presence of suggestive areas or explicit content. What does it mean? Well, before we kind of dove into this domain back in 2017, the standard solution was marker for safe or unsafe, right? One of the things that we realized is that that's extremely subjective, because what could be safe for you could be unsafe for the person next to you. What could be unsafe for you could be completely safe for the next person next to you. So we decided to create the product with a little more control back to you as a developer, as you as a customer. And the way we do that, we not only tell you that there's a suggestive content, we tell you why we think it's a suggestive content in a hierarchical relationship. So now you could imagine creating workflows internally, depending on what triggers a suggestive to choose to use or not use that image. So for instance, here you could see that the reasons why we identify a content to be explicit, if we find nudity, graphic male nudity, sexual activity, partial nudity, and so on and so forth. The same way we detect suggestive content and tell you that we think it's suggestive because they're female swimwear or underwear, which now, if you're creating a fashion magazine or a product site for swimwear, you'll be perfectly okay with, even if it's suggestive. Whereas if you're creating a different site, you might say, no, I don't want this sort of content here. So you get to control, fine-grained control of what you show and what you don't, what is safe and what is unsafe. So we don't take a stance on what is safe and unsafe. We let you decide what is. We're providing you a lot more information that you could make this decision tree out of. Of course, nothing stops you from using the top-level labels to decide what you want to do with it. But if you want to go deeper, you could do that too. So the granular output is better control for you. A great example of this is a dating site, Coffee Mate Bagel. The interesting problem they have to deal with is that there's a lot of challenges in making sure that their customers are not seeing inappropriate content. Because the moment a site like that starts showing inappropriate content, it's a loss of trust of customer. So they worked with us, and they have built a solution that they're able to provide high accuracy solution for their customers, a much better customer experience, a much safer customer experience, a guaranteed customer experience that they're able to provide using content moderation from Rekognition. Now, so this is kind of what media discovery is all about, with how you could use Rekognition for media discovery. And now, that we're discussing media discovery, I realize I actually don't know of any expert that could talk about it more credibly than my good friend and CTO of Pinterest, Vanya I knew I would do that on that last name. Vanya, I wouldn't bother him. It's my pleasure and privilege to invite Vanya to the stage now and give him the control. You should say your last name.
Thank you. Thank you. I'll have a little quiz for Ranju on my last name after the talk. So, hi everybody, I'm Vanya. I'm a CTO at Pinterest. I'm here today to talk to you about our collaboration with the Rekognition team, and specifically what I was thinking about talking is about the process of deciding how to outsource certain part of your stack to another company, which is a scary thing for a company like Pinterest, but also I'm sure that companies that you're in, that process, the decision-making of what you do in-house and what you do with a partner, it's really important and kind of defines your product in many ways. So what I'm going to do is I'm going to give you a little context on Pinterest just to set the environment. First, I'm going to describe Pinterest as a data. What data do we have? And then I'm going to go a little bit in the product and see how the product looks. So that context is there so that we can then dive a little bit in the technologies that we are using at Pinterest to power the product. And then I'm going to talk about the decision-making of what you do in-house and what you outsource to others. Okay? So Pinterest is maybe one of the real large-scale data companies. So we're one of the, I would say, one of the top users of AWS, and that is because we have a tremendous amount of data. We have about 175 billion pins. Okay, that's a number that's really hard to comprehend. Our brains are just not made to work at that level. Those are objects that people bring to a system, and then we have about 250 million monthly active users. Okay. Most of the content is brought by people uploading. We have also content that users bring in. We are mostly mobile these days. And our goal is to help people discover and do what they love. So I want to contrast the Pinterest goal to other companies because we don't really want people to spend time only on the platform. We want them to find ideas that then they will do in their real life. So how does this all work? Let's see. Oops, there's an animation there that's not working, but let's try again. So how does it, while you're staring at the white slide, I can explain to you how it works. So we have objects that are called pins. Those contain an image and a textual representation that people bring into the system and they pin into boards. So those around 200 billion pins organized about 3 billion boards. Boards represent a grouping of the pins that the user wants to see together. And the very uniqueness of the Pinterest data set is that those boards represent very fine-grained attributes of the pins. Like the same pin can appear in a modern kitchen, it can appear in blue tables, it can appear in kitchen fireplaces, and this way we triangulate the real attributes of these images. At the very core of everything we do at Pinterest is our data set because it's very, very unique, and such a scale and such a finesse of curation does not exist anywhere else. Okay? So we do care about, Pinterest is a very user-centric company, and that's where these slides come in. For everything we do, we take it from a user experience standpoint. We want to make sure that we give the best experiences to our users, and that's why in a recent survey, we have ranked among the top brands in the US, according to our consumers. Okay, so At the core of Pinterest is visual discovery. And visual discovery happens in multiple different ways. Through search, where the user can use part of an image or the whole image to search for other content, or through personalizations, where we take users' past interactions on the platform, and then we build specific queries to find content, okay? The process, in general, we call visual discovery. And through the next couple of slides, I'm going to give you a couple of examples of technologies that we do in-house to facilitate this process. Our products are best of breed. Continuously, in evaluation, both internally and externally, our products perform much better than some of the larger competitors. So we use convolutional networks in many, many different ways. You know, at every point of time, there are thousands of models that are trained, deployed, and tested. I think the majority of models in production are actually those that you have in experimentation and not those that are deployed to users. We use convolutional networks. One of the problems we solve is image classification. We have taken the state-of-the-art image classifications algorithms out there, and we have adjusted it particularly for the Pinterest data set, and we're getting much better results than out there. So in image classification particular case, we have decided to build something in-house because we can take advantage of our data in a different way than what's some more generic algorithms, including those that are built by our friends at Rekognition. We also have unsupervised and semi-supervised ways to extract features from images and figure out, you know, in some metrics distance space, what are similar images and what are different. There is a whole set of methods that we use here that capture different kind of interactions in our data set for supervisions that we combine eventually into our products to provide content to our users. Finally, we do object detection. We use algorithms like faster readers, CNN architectures, which does jointly the segmenting of the image and the classification. We have had really good results with that. And here again, we have taken more standard network architectures and we have modified it to use Pinterest graph and the specific of the Pinterest images to get better result. This type of things we do in-house. All of that is then combined in a product like Lens, where you can snap a photo of an object and we'll give you similar content from the platform. What happens here is offline. We analyze the images, we segment them, we find the objects, we classify, we build an index of that. And then online, when the user snaps a photo of something, we featurize that, map it to some embedded space usually, and a couple other techniques. And then we look for similar objects in our index to serve the user. So that's kind of taking the technologies and then putting them all together. So now, the key question is, why do we need to partner with AWS when we have all of this? And we have a full stack computer vision team that is able to build all of this and much more. The reason to go outside is twofold. I think, first, the problem at which Rekognition solves it is a more general problem. They look at many different customers. And that could be an advantage and a disadvantage for a client like us. When you look at multiple different customers, you obviously get more data and you get that broadness, but also you lose some of the specificity. So it's really important to understand that boundary of specificity versus generality. The second thing is that although with a relatively large company, I don't know, 1,500 people, I guess, altogether like ours, there's always more things to do than there are engineers in the building. So we have purposely focused our engineering resources to work on the key advantage for our users based on our data set. Understanding taste, understanding style, using the Pinterest data set in a particular way, that's where we use our internal engineering resources. For things like moderation, the detection of bad content, there is no particular advantage from the Pinterest data set for us to use so that it will be worthwhile for us to develop in-house. And then by working with Amazon and having a close relationship where we give them feedback on what's going on, we take advantage of the broader set of users where they have other data set to find this bad content on the internet. And finally, we're proud to help improve the platform that will benefit everybody on the internet, see a lot less bad content. And these are not things that you want to see, like starting from child abuse to violence, to self-harm and all of that is something that we all need to work together to take off from the internet. Now, even in these cases, making a decision to outsource something at the level of services as Rekognition is something new, I think. And I don't know an example before where companies make this type of decision at this level of services. So there's all kinds of organizational, technical, and even emotional issues within the companies to make this step forward, to make this step that you can trust somebody to do some core work for your users, for the safety of your users. But I think this is where the world is going, and more companies will be linked by using this type of services across. And it totally makes sense to look outside for this type of services when they're not taking core advantage of your data and are not aligned narrowly with the goal of your company. Okay? That's all. Thank you very much.
Before I move on, how many of you use Pinterest? So raise your hand, please. For the rest, that's a homework. I have, I'll tell you, I've been using Pinterest on and off. I'm not a serious user, and then last year I started a fairly major house remodeling, and my the designer I was working with, her first thing was to send me a set of pin boards to say, look through these and find what is, and I've been amazed with the quality, the experience that Pinterest creates, the lens capability. I could take it to part of my kitchen and show, okay, here is I want to make it look like that, and I get hundreds of really relevant experiences. So it's been an amazing experience. Definitely recommend you trying it. Thank you, Vanya. Has been a really awesome partner in this journey with us, and we'll keep improving the product with support from customers like you. Moving on, that was a media discovery story. Let's talk about what does it mean to improve customer engagement, right? And what are the common use cases? What are the common patterns we are seeing for improving customer engagement? So customer engagement comes in two flavors today. You could analyze who your customer, know who your customer is. You could do it at an aggregate level or at an individual level. The aggregate level is most of the time anonymized, right? It's about knowing, if I were to know how many male, female came into this room, what was the age range distribution of the attendees, I don't need to know who each of you are. I just need to know that specific attribute information and then aggregate across you. Now, typically in the past, the way you knew that about your customer is that, bless you, is that you actually had them fill up a form, or you had to capture their information, or you captured their email address and then send it to some marketing tool that provided you all this information, and you created this information. Whereas now with Rekognition, all you need is a simple sensor that can capture, just look at the faces of this individual and do our face analysis API to know what gender, what age range, what emotion they had. And it's extremely powerful. So if we had a sensor in the front door, I could have right now in real time with high accuracy tell you what is the distribution of age range in this audience, what is the distribution of gender in this audience. And all of you look fairly unhappy with me right now, so please smile, otherwise I'll feel bad. These things are real time, and you could get real time information and very, very low friction from your customer, right? You're not getting them to have to fill up a form, go in front of a customer. Think of hospitality. Imagine if you're a premium platinum member, if such a thing exists, of a hotel. When I came into Wynn, where I'm staying this time, I had to wait for almost 45 minutes for check-in at 2 a.m. or something, which is bizarre. But if I'm a premium platinum member, I'm waiting for 45 minutes, and until I get to the check-in counter, my status is not known. Right now, what you could do is put a sensor, you know who this individual is. As they walk through the door, you know that they matches with the database that you have created of the premier customers, and know a premier customer has walked through the door. Now you could provide much higher quality service to this individual, even if it means that they have to wait for 45 minutes, maybe I'll wait with a glass of mimosa, Feel good. Maybe not at 2 a.m., but you can offer it, right? So that's the engagement story that you can create with Rekognition. Now, the other thing you could do, let's say a customer is standing in front of a store or an experience or an ad or on your website, and they're all of a sudden looking happy to looking very unhappy. You could immediately create an automatic chatbot. You could get a customer service agent to them. You could go ask them what's going on if something changed. Are they looking for help? You could do this in real time again. So this is kind of both at the aggregate level, understanding what the customer is and where they are, what they want to do, or in a specific level, knowing who they exactly are, and if they're part of a larger membership group or a loyalty group, and providing services, very, very important, and it's easy to do today. So here, if you look at the example, for these two faces, we are able to find out that this individual is wearing sunglasses, that they have accessories on them, that there are eyeglasses in this thing. So all these features can be extracted and could be aggregated. So people coming into your store, if they're all wearing, if majority is wearing eyeglasses, maybe it makes sense for you to stock some eyeglasses for them, right? So information like this is natural. You don't have to have them fill a form anymore. You don't have to, and again, these are aggregate level information, so no privacy, right? You don't have to know who these people are. You don't have to capture their face and you just analyze the face. We don't store any of this face. We give you the attribute back and you're good to go. As I said, you learn more about the demographic. You know what gender, what age range, what their emotions are, and that can be extremely useful, as I talked about. Last week, we announced a fairly major update to our face detection. I'm very excited about this again. If you have tried Amazon face recognition before, I would strongly recommend try it again. And if you're already in production, I think you'll get the benefit out of the box. We have improved our face detection overall by many percentage points, but specifically for the challenging use cases, right? What are the challenging use cases? Typically, the biggest area of concern, the biggest area of adversity, if you may, to deep learning-based face recognition or detection comes from 3 areas. Pose means if you have a camera that's pointing here, you're looking up my chin, it's not really good for finding a face or recognizing a face. A lot of physical and face or environmental concern creates noise, which noise could show up as illumination. Right now, you guys can see my face because this auditorium is specifically built with all the light pointing at me. I actually don't see your face that well, because to me, your face is against the backdrop of a very bright light. So illumination is a really difficult challenge at times for face detection and recognition. Of course, the final is blur and occlusion. Now, this could happen because somebody gets too close to a camera and it's blurry, or their hair is coming in front. If I put my face in front of my hand in front of my face, it'll cause different sort of occlusion. Finding faces in them and then recognizing them is a hard problem. Well, with this release that we launched last week, we are able to create much higher accuracy detection and recognition for all these sort of very, very challenging use cases. And you get to benefit that without any lines of code, as I said. Just go use the API. Out of the box, it works for you. And it works for both images and video. A natural benefit of higher detection, higher accuracy detection is higher accuracy recognition. And again, the way you want to use recognition is to verify your customer, right? That could be done by either saying registration. I know when we had reInvent and the New York Summit, not reInvent, New York Summit for AWS, we actually created kiosks for face recognition where customer, when they registered, if they upload a face picture, they could just walk up to the kiosk and get print out of their badge. So they didn't have to go stand in a line, talk to somebody else, provide their last name, first name, and all that information. Just face recognition could get them the badge. So this is about getting a better customer engagement, customer experience. Imagine the hotel story that I talked about. If you were to build a solution for your best customer, and this could happen for any retail space that you manage, knowing who your customers are and providing the best quality of service is essential, and you could do that today. Now, this comes in 2 flavors. You could compare one face to another face, which we call it face comparison, or you could compare one face to a collection of faces that you might have already created. Now, something to remember here is that recognition, your data is yours, which means we do not use your data for training or improving our model without an explicit consent from you. And that's a very, very important distinction to keep in mind. So in terms of security, privacy, you get the best of the breed while you continue to get the best of accuracy, ease of use from our solution. A great example of know your customer is Ayla Credit. They are providing a bunch of finance solution to their customer. And the biggest challenge they had is that their customer base is fairly demographically diverse. And they tested all face solutions that are out there. They found Rekognition to be significantly better than any of them, and hence they're able to provide a much better customer engagement story today using Amazon Face Recognition. K-Star Group, I really love their solution. It's so innovative. So they have created a face ticket service. So they manage these live events and concerts and all the stuff. Here now customer can buy a ticket and their face becomes the ticket to admission. So it provides a much higher engagement, much secure experience, and they're able to roll this out using our real-time face detection, face recognition solution. Let's talk about how we can get started. So we covered those 3 areas as I talked about, right? Safe content, moderation. We talked about media discovery. You heard Vanya talking about how Pinterest is making choices for themselves in this domain. We talked about customer engagement using Face. You could use all of this today. These APIs exist in multiple regions. I'll talk about that a little bit. How do you get started? You could go to the Rekognition console, and that URL up there. And you can try out the product for yourself, upload your own images, and there's a bunch of experiences we have created. You could try it out quickly. You could start with a CLI. You could start with an SDK. Very easy to use. You could literally get it in production in a matter of days to weeks, depending on what problem you're trying to solve. Let's talk about getting into a bit more of the technical detail here a little bit. We see a few technical design patterns emerge in how customers are using us. As you know, probably worth calling out, Rekognition actually supports 2 inputs, both for image and video. One is for image, we allow you to upload the binary image object as a base64 object. We also take S3 URL as an input. For video, we can take an S3 stored video for archive video or a live stream input for video. So these are the 2 formats in each of them we support. Now, this example shows you where image or video is already stored in S3. If you want to do a direct upload, at this point you could call a Lambda trigger function. Rekognition APIs are available as part of the Lambda trigger function. You could literally cut 2 lines of code. You could, for every upload of image, get through a deep set of analysis done against images and video in real time. This information then could be stored in Elasticsearch, in DynamoDB, in Redshift, or you could just create notification for yourself to make a decision in real time if you need to. Which means if you have a sensor that's pulling video for every 5 minutes from a door like this, uploading into S3, and every time you find face in you're not expecting anybody to show up because these events are over and these rooms should be empty. You can pull that 5 minutes of video, upload it to cloud, and see if there's a face detected in this thing. If a face is detected, you could then notify the corresponding authority to say, hey, there's a face, go check if somebody should be there, right? You could also do the same with live stream, depending on whether the need is real time or the need is just analytical, which you could do in a high latency environment. And the results could be stored in database. You could create search indexes with these results. You could create real-time decision tree using SNS, SQS, and that's your choices. The APIs, of course, as we talked about, labels, faces, moderation, and text. For a lot of the examples where, again, we strongly recommend where your experience impacts customer sentiment or their overall accuracy is very, very critical for the operating function of your business or application, we recommend using human in the loop. What does that mean? You would, again, either from a live stream or a base64 image or an S3 URL, you call Rekognition, you get the output. We could help you with that. We today announced, Andy announced SageMaker Ground Truth. You could use SageMaker Ground Truth. You could get the annotation from us, pass it through that system, and get a human being confirm that, yes, we are seeing what Rekognition thought it is, or we are seeing it not, because there are some conditions that there are false positives, reality of our world, and get that high accuracy results that you could use to then make decisions. So that's kind of the way to think about if you have really, really critical use case, where the accuracy dictates success of your business, we recommend at least from spot check or continuous check or human review or human in the loop. This is a great example of Rekognition for streaming video. And this actually is the close to the reference implementation that supported the royal wedding event that I keep talking about. And the idea here is that you could get a live stream feed. Rekognition today supports Amazon Kinesis video stream. So you register your live stream with Kinesis video stream. You provide us the ARN. We are pulling Kinesis video stream to see if there's any stream from your particular ARN, and then we, in real time, analyze this video. Today we do face search against a collection that you might have created. Once we find a match or we don't find a match, we can create a notification for you, which you can use that to do a decision of yours. You could also do a get to see if the job is, if you have any information based on the SNS notification that you get, right? Similar workflow could be created for archive video stream. Of the archive video, not video stream, archive video, in the case of archive video, because of the length of video, it's an async workflow. So you start the job, you tell us which video file or video artifact you want us to process. We have a get API that you could poll to see if the job is completed. It provides you the state of the job. Once the job is provided, you'll get an artifact, which is basically the manifest of what we found in the video, which could be a set of labels and the time series manifestation of the label from the video. It could be people that we found. It could be objects. It could be things that we have found that are unsafe or inappropriate. And it could be text that we have found from the video. And that's all through 2 API calls. So to wrap things up, as we started, Rekognition, deep learning-based image and video analysis service. We are continuously improving this product. We are continuously adding new features. And if you guys have specific requirements, feel free to reach out to us. Let us know what your requirements are. Happy to support those. Some of the key benefits is that you are getting state-of-art capabilities, right? As Vanya talked about, that the partnership with customers like Pinterest and others help us keep moving the envelope forward and keep a state-of-art solution available for you. We are continuously improving, right? As we get customer feedback, we have separate teams that are continuously working on each of these features to collect data, to improve these models, to solve the hard problems, the hard challenges that the customer is telling us we need to solve. And so you're getting this out of the box, no lines of added code needed for you. Our APIs are very easy to use. A lot of customers have given this consistent feedback. We have spent a lot of time thinking through how to make the APIs so easy that you don't have to worry about it, both in terms of how we manage the input as well as the output, allowing you to do a very, very rapid integration. The service is extremely low cost. Insofar you can build the solutions and host them yourself and run them, we believe you'll get a much better bang of your buck by using our services because we have taken a lot of care and attention to make sure they're running low cost. It's fully managed. It's a serverless. You just call the API, you're done. You don't need to provision. You need to manage your instances. You don't need to do any of those work. And then finally, I think it's a very important point here. Your data is your own. We do not use, share, look at your data, improve our model using your data unless we have explicit consent from you. So that's a very, very important distinction in my opinion. Rekognition is now available in 9 of these regions, so depending on your businesses, you can have Rekognition available locally, both images and video, and we are very rapidly increasing our footprint for all regions, and hopefully in 2019 we'll be in all regions that you can have AWS access to. Quickly before we leave, these are some of the related sessions that we're talking about. Hope to find you guys at Venetian at 6:15. I'm going to tell you about the new service that we're launching today. We call it Amazon Textract. It extracts information from document, very different than what we have built with Amazon Rekognition. So hope to see you guys there. Wanted to thank you all. Thank you for the time, and thanks, Vanya, for the time given to us and sharing your ideas. Hope to see you around. Thank you.